the Spark introduction. Now, good. So there are some questions related to programming. Let me just note them down because few reasons. One, the programming language discussion is generally requires more time, and second is the discussion and debate is more like political than the normal one. So question from Robin is, could you contrast and compare Python, R, and sorry, question from Robin is, what Java can be compared to Scala? Is it the Java or the JavaScript? So Java and JavaScript are two separate languages. Java is more like the next version of C++, while JavaScript is a really friendly version of, say, you can think of it like extremely simple language, and it's a combination of Lisp and C. Okay, so JavaScript is generally used in the client side of the browsers, though JavaScript is extremely flexible and can be used on the server side as well. Today, if you are building a product and for your product you need a domain specific language, you will generally go with JavaScript. Okay, so let's say earlier people were creating the, like Microsoft has Microsoft Excel macros, which are written in VB. Lotus has Lotus script. So all of these languages are no longer required. You can just embed JavaScript. Okay, so JavaScript is extremely flexible and omnipresent, while Java is basically very type safe language, as in you have to define the data type of everything and so on. So it takes a long time to code it in Java. But if you are writing a program in Java and you're compiling it, 90% of the typing related problems are solved or are caught during the compilation. Therefore, Java kind of language, which are type safe languages, are generally considered in enterprises where you have the build cycle of a product. Many engineers are working together, they're writing the code, and they do the compilation and then push it to the testing, right? So Java is a choice of enterprises. So okay, Java is a choice of enterprises generally. Okay, and JavaScript is basically a web programming language as of now. As well, it can be used for server side, or in case of domain specific, right? So let's say domain specific, let's say Google Doc came recently, right? So in Google Doc, you can actually customize everything using JavaScript. So you can actually create your own custom engine. Let's say you are writing earlier, like for example, at T-Bits in the previous company. So what we built was, we needed a way that our customers could write their conditional rules. So we needed to create a programming language. So we first tried to write our own language, which was fine. But then we realized that we could just use JavaScript off the shelf. Okay, so basically we could just take a JavaScript code and run the JavaScript code and check whether it's returning true or false, and that's how it was. So it is easier to write rules. Now, this third language called Python. Python is basically very very friendly, right, and generic. Okay, and Python can't be used as of now for for controlling the browser, but Python is very friendly and generic. So in server side of okay, web programming, yes. So server side, I'll just say Node.js, for example. Okay, and here Python is used in server side, data science, machine learning, etc. Okay, so since Python gives interactive shell and it lets you interact with the objects very quickly, and it's really easy. And as of today, people consider this as the first programming language. Okay, so yes. Now, question is the programming language that we will be learning as part of this course is Scala. Where does Scala fit in? So Scala actually fits in here. Scala, in case of enterprises, most of the work is going to be moving to Scala. Okay, because Scala is like a combination of Java and Python, and it's relatively easier to code than in Java, and faster to code in Scala as compared to Java. And the way in Python you could create class very quickly, call the functions, create a function anonymously, and all those features, the same features are available as part of Scala. So most likely in the enterprises, Scala will be used over Java. All right. A question from okay, so there are quite a few interesting questions. I'll just take these questions and share with all. Okay. Another question is that Sandeep, I want to use IDE to develop Scala Java code. Is it possible to connect to Hadoop Scala infrastructure on CloudxLab from my laptop and work with them? Okay. So basically, we don't have an online IDE, which is very friendly as of today. So what people generally do is, okay, let me first complete my first question before I jump into another. All right. So yes, so this is the kind of thing that the various programming languages are, and we will compare probably after finishing first round of let's say after Scala. Okay. So after Scala, we will again revisit this comparison. All right. It's a hard to do the comparison, but we will do the comparison after the Scala, because at least we will be aware about couple of languages. In the meantime, my suggestion to all of you would be, unlike normal languages, unlike human languages, learning programming languages are far more simpler because they all have same syntax, same constructs, and a lot of similarity. There are minor dissimilarities between languages. Those are the only things that you need to figure out while picking up any language. So, so I would love to answer these answer in more details this question, because as you go ahead with the course, we will give you example of all of these, and then you will realize that almost all the languages are similar. Okay, and it is not too much of a concern. First course of Spark, we ran it in Python, but then we realized that most of the certifications and most of the enterprises are demanding Scala, so we shifted the course to Scala. All right. So it has been easier for me to write code in Scala. And though I am a Java developer for have built a lot of things in Java, but if I have to do something that needs to run in Java environment, I'll do it in Scala. And if I have a flexibility of choice, then I would probably pick up Python. Okay. And so my suggestion would be that while we are learning Scala, your learning of Python is going to be simple. So I think two programming languages would be good enough, Python and Scala. All right. If you are building a web application, then learn JavaScript as well. So the hard answer to all of you is that one language is not sufficient. You might have to go with multiple languages. The good news is that multiple languages are actually similar to each other. So it'll be easier for you to learn multiple languages without having to worry too much. Okay. In general, most of the engineers, senior engineers I have met, they know at least three languages, and they are comfortable with picking up any new languages. Okay. Also, when you are going with a product company, when you're joining a product company, people just say that what is your favorite language? Okay. And they ask questions in they ask like, can you solve this? This is the end problem. Use any language to solve this. Okay. So it's better to, have good command on any one language as well as knowledge of the other languages and rest of if you are good with one language. So it took me long time to learn C. Okay. It took me long time to learn C programming language, but learning Java after that and learning C Sharp, learning Visual Basic and JavaScript was really quick. Okay, so you will feel that way also, that learning any other language, once you have mastered or you have been able to construct your thought in a particular language, then it's really easy to pick any other language quickly. Okay, all right. Question from Alok is, what are the main languages should I learn? I prefer Java, Scala, and Python. I think Scala, Python, and JavaScript are three languages. Okay, Python, Scala, and JavaScript. Okay, these are, if you have to choose three languages, these will be the one. And reason is that, so Scala would eventually replace Java because it's faster than Java, as well as it basically compiles to the same code as Java. So, okay, sure. Let me just paste the answer here. Okay, so I'm going to, although it's kind of a very tempting to get into this discussion for me, but uh, I'll hold on and move on to the topics. All right. So, is there any? Yeah, Sachin's question is yes. SQL definitely. SQL is okay, kind of must when you are dealing with the most of the engineering. Along with that, go through Linux. Okay, so you must. Okay, so if you are good with, say, these three things, Linux, SQL, Python, then none of the computing environments would, scare you. Okay, you'll be able to pick up anything really quickly. Okay. And Vidya's question is, how about regular expressions? Yes, regular expressions are basically, those are part of the languages, and you will learn that, like the way we learned regular expression as part of Python. So those are, and regular expressions are also used in Linux. So those are good, nice things to learn. Okay, that is not really, you know, it should take a 1 day or so. So yes, with respect to that, it's like regex is good thing to learn. All right. So yes, so I would say that these three, at least one programming language. Okay, at least one. And when say at least one, it is Python, probably, and the regex. So basically, if you have one programming language, you are comfortable with one programming language, and you are comfortable with Linux and SQL, trust me, everything else will be extremely simple for you. Okay, that's why I have created this nice tutorial for all of you. Those of you, those of you are trying to learn Linux. Okay, so here you must go through this one. Okay, you must go through this one. It's extremely simple. I've tried my best to keep it simple. And good part is that a lot of people have asked questions here. You can say, see, Bintao has asked question, and there's a very healthy discussion here. And this actually is quite helpful for people to, you know, learn a lot of things here. So this is extremely simple, and this will be very useful for everyone. Okay. It'll take a day or two. All right. So A question from Noor that I'll appreciate if you can guide how to. Yes, I think that is something that is coming up again. So yes, I'll try my best, and maybe we can have a little deviation after the first session and show you how to start programming in Python with Spark. So since whatever we do in Scala, we'll have a parallel in Python. So as we go ahead with Scala, you will be able to do entire thing in Python as well. Okay. So if we finish the session with Scala, I guarantee that if you are coming from Python background, you'll be able to do the same thing using Python. Okay. All right. So this is the, okay, this is the basic general discussion. Now there is one another question. These are very important questions. Question is, besides as lab and learning for primary purposes, on CloudxLab also be utilized as an online ID for developers? Mm, so it is, yeah, basically on CloudX Lab you can use Python via notebook, use Scala via notebook, and JavaScript not yet, but yes, I have installed here the Node.js, right? We have installed the Node.js. If you want to practice Node.js, you can practice that. But I'll keep in that mind that if I could come up with a framework with which you could quickly build websites and experiment with HTML, CSS on CloudX Lab, that will be quite useful for people. All right. So, okay. So we will be doing actually most of the exercises are like okay. So yes, there are a couple of projects we will be doing in the class, and there will be one assignment in the end, which you will be doing as part of your own. So let me see if we can add more projects as part of this course. Okay. A question from Binta is, could we, okay, on CloudX Lab, what is the default tool to write Scala? Default um, tool to write. Okay. Okay. So yeah, we'll cover that. Now I think we are ready. Question from Robin is, can we also build websites using Scala? I think people have written frameworks for the same, so it should be possible. I'll have to check if, okay, we'll be checking the name of frameworks. Okay, it should be possible. I think there was one when we went through the Scala web frameworks, so you could use that. All right, wonderful set of questions. Question from Robin is, how do we access the uh, notebooks of Python and Scala in CloudxLab? You go to cloudxlab.com and then go to my lab. Okay, you go to my lab, and here you click on Jupyter. Okay, so this is where you have the folder structure and everything. Here, when you click on new, you will have access to Scala, Python, R, and even the Bash. Bash is like a Linux terminal. Okay, and so on. So using this, you can enter. Okay, so let's start. All right, I'll also give you more references on the blog. And here we have, if you go to my lab, we've written some more things here, like how to make use of lab more better. And this is Apache Spark 2 instructions. And this is again to run the Spark, Python Spark using these instructions and so on. All right. So these are, all right, great. So we are done with basic introductions of the topic. So I'm going to switch between these two, the slides and my lab. Okay, right, it's not required. I'll go back. This is good. This is same thing. All right, so I'm going to use probably a terminal from the Jupyter because, okay, wonderful, wonderful. So here we go. This is what we discussed last time. So we talked about the basics of Spark. Spark is a fast and general engine for large-scale data processing. So I'm going to go a little faster because I think that we have already covered this. It would not make sense to keep repeating it. All right. So it's a really fast MapReduce. It's like 100 times faster than Hadoop MapReduce in memory, 10 times faster than on disk. It builds on similar paradigm as MapReduce, and it is very well integrated with Hadoop. Okay, so when we talk about Spark, basically, Spark can read and write data from various data sources. Okay, Spark can read and write data from various sources. Also, Spark can run on your existing Hadoop. If you have any organization, if you were having Hadoop, that means you can run Spark without any installation. Without any new installation, you can just run Spark on top. And then you can also use Spark using Amazon. You can also use the less known version of less known distributed computing environment called Mesos. You can run Spark on top of that. What are these environments? Let's say you want to do distributed computing, you have multiple computers and you want to do some kind of processing, then you either use Hadoop or you use Mesos, or you, in case you're using a Spark, you can use the Spark's standalone version. Okay, in this case, you will have to install Spark on all the machines and then run it. Okay, so this is called standalone version. Now, Spark can read from all kinds of data sources, from HDFS, HBase, Hive, Tachyon, Cassandra. Spark can read from all these data sources. Now, to interact with Spark, one is by the way of raw coding, like the way we have been doing in normal programming, that read this data, read that data, execute this, execute that. Or we could use data frames. Meaning, let's say if your data is tabular format and we want to process data in tabular format, then we will use data frames library. It's basically one layer above this one. Okay, instead of you dealing with data row wise and column wise, you ask data frames to load the data from data sources, and then you execute your queries in data frames. Queries in data frame can be written in SQL kind of language as well as R kind of language without having to write for loop or any other code. So this minimizes your coding efforts. Your coding efforts are minimized if you're using data frames, and the code also looks smaller and cleaner if you are using, say, SQL kind of language on top of structured data. The problem is that data frames are great for structured data where data is in the form of tables, but it's not great when the data is not in the form of tables. Okay, you cannot do things like image processing or say complex data processing using data frames because that's generally for tabular structure. Okay, so data frames is a specialized library on top of Spark core. Similarly, we have streaming, the Spark streaming. This is again a tiny library on top of Spark core, where all it does is it keeps executing the code you have written in Spark core again and again whenever data is coming in. Okay, so you can think of streaming as an infinite loop which is executing your code again and again as and when data comes in. All right, then we have a nice library called MLlib. This is actually a really, really well progressing library called MLlib. It's machine learning library. Using machine learning library, you can get your work done in distributed fashion on multiple computers. Okay, so MLlib essentially takes the raw data and runs on in the distributed environment. Sorry, MLlib essentially provides all the algorithms in a distributed environment. So whatever you want to do on humongous data, whatever machine learning work that you want to do, like recommendations and other machine learning works, then you can out of the shelf you can use the MLlib library. Instead of writing your own algorithm, you already have the algorithms available here. The GraphX, again, there are many works in which we need to process the data in the form of graph. For example, finding the rank of most popular people on Twitter, or finding the thought leader on Facebook or LinkedIn. That's basically work of a graph, right? There are many use cases of graph. So graph processing is done through these libraries called GraphX. GraphX is not a database. GraphX is just a library, bunch of code written for you. You will be executing this code. All right. All of these are not database or data sets. They basically piece of code. This is somebody wrote these nice library for us so that we can save our time and just use them instead of writing our own. Okay. These are the say your data is in any of these environments, so you can use Spark Core or any of these libraries to read the data from here and do the processing. Okay, so there are a couple of questions. Let me answer before moving forward. A question from Hitendra is Tachyon another DB? Tachyon is basically called Eluxio. It's essentially a file system, high performance file system. It is not proprietary. It used to be open source. Okay, so Alok's question is data frame and streaming is not included in Spark Core library. So I would say that this whole bundle comes together. Right? Whenever you're installing Spark, all of this comes together. Just like in Java, we have core package, core Java, and then there are libraries separated so that we are able to understand that, okay, this is the core and these are the extra libraries which are written later. So for example, data frames was written later, streaming was written later, MLlib was written later, and these all were written later. First, Spark Core came. Okay, and there are more similar libraries would be coming up, and there is an improvement happening here, right? So basically, if we separate out the packages, it becomes easier to make changes and easier to contribute and easier to upgrade. Okay, the Spark core will basically change rarely, while these individually will keep on upgrading. A question from Sachin is, can you give an example of streaming? Right. Here is a very important question to understand what does it mean by streaming. Let us say there is a real-time data coming in. Just like you remember our discussion in Flume, we were producing the data continuously and Flume was consuming that data, right? In the same way, let's say we want to make changes to, all right, let me just say, let's say there is a continuous activity happening on your website. And what we want to see is we want to do that. We want to analyze this activity continuously instead of we running the script again and again, or we are scheduling which runs it again and again. The program runs indefinitely. The programs runs forever. The streaming applications, they run forever. Okay, this is a very important idea, and this is something really different from the batch execution. Okay, there are two kinds of programs. One is batch and other is the streaming application. In batch application, probably that's what we have done mostly, that we write a program, we run the program, it gives the output and so on, right? So batch programs are something that ends, right? While the streaming application are mostly the infinite loop, they keep on going forever. As long as there is input, they'll process. If there's no input, they'll wait for the input, like a mail server, like a web server, like any other background processes. They keep on waiting for the input. So most of the background processes are like streaming application, or we can say they call them unbounded data set processes. So streaming is basically that kind of programs. Okay, so streaming applications are infinite loop. They keep on running forever. But when there's input, they process the data and give the output. Otherwise, they just wait for the input. All right. So I hope that gives you a picture of what is streaming. Sachin, does it make sense to you? A question from Robin is, in streaming, if ever continuous running programs suddenly malfunction, stop or can't process, how to fix and restart? So generally, we basically put something called monitor on streaming applications. And in case it shuts down, we just reboot the service. That's all. We just restart the service. Okay, great. A question from Alok is, RDD is part of the core? Yes, RDD is part of the core. That's the heart of the whole system. We'll talk about it after this. Question from Mohammed is that streaming Twitter feeds coming in continuously. Yes, that's right. Thank you, Mohammed. So let's say we want to observe the sentiment analysis continuously, then you can use a streaming application to get the data from Twitter continuously and represent it as a graph, like whether there's a positive sentiment about your brand or your product or negative sentiment. So we can plot the graph continuously. That is the example. All right, there are a couple of more example. One of them is quite popular from our side. I think that's kind of used by many people. Okay, so there is yeah, real-time analytics using Kafka. Okay, you could try this one. Okay, this is another example of how do we build this. Okay, now going back and here, thank you, Mohammed. And next question from Robin is, are data frame streaming MLlib and graphics libraries all built in when we install Apache Spark? Yes, they come as a single package, just like when you install Java, all the libraries come with it. So, and we don't have to explicitly install these libraries separately. Okay. Question from Binta, what are the components of Spark Core? Spark Core basically is that RDD and all its operations are in RDD along with the driver and other parts. You will see that soon. Question from Grishma is, data frames does exactly what? Basically, data frames allow, like you remember in case of MapReduce, we had to write so much of code and we needed Hive to do all of that, to basically provide you a SQL query kind of language. Data frame does that. Instead of you writing the logic in for loops and while loops and other constructs, you basically use SQL kind of language to process data in the tabular format. That's what data frame provide that interface. So if your data is structured, you just use data frames and don't have to touch anything else. Okay. Question is, what is the language these libraries are implemented? Good question. These libraries are implemented in Scala. Okay. These libraries are implemented in Scala, but good news is that we can interact with these libraries using SQL, R, Java, Python, and Scala. Okay, Scala being the primary language, but you can do almost everything with Python and Java as well. Though with SQL, you can only process data which is structured via the data frames. Similarly, in case of R, If the data is presentable in data frames, then we can use R efficiently. Otherwise, it is a little more tricky. All right, wonderful set of questions. So this is how we interact with the Spark. All right, any doubts about it? This is very high level overview. In real life, this knowledge is not going to be of much use. If you are building something, this will give you a overview and a picture, but unless we do the hands-on, this will not make any sense. All right. So a question from Prashant is, what is structured streaming? So if we are processing data in tabular format, if your incoming data is in tabular format, then we generally use a newer component of streaming called structured streaming. Instead of using the RDD based streaming, we use the structured streaming. We'll cover the structured streaming as part of this. Question from David, is it possible to add short description to each block? For example, Hive SQL-like interface? Sure, sure. I'll just make a note of it. Okay, so let me just put that as a comment for myself, and that will be useful. Okay. Where we will use Spark SQL whenever we want to process the data here. This SQL is called Spark SQL here. Whenever we want to process data using data frames, then we'll use Spark SQL. So data frames turned into Spark SQL actually. Data frame turned into Spark SQL, and we alternatively use the two things, Spark SQL and data frames. Same name for the two things. RDD is resilient distributed dataset. That's the core of the entire thing. We are going to go into very much details about RDD, and we will try to solve problems using RDD. Okay, can these libraries also interact with JavaScript besides Java? Can these libraries interact with JavaScript beside Java? Okay, this is something I would love to explore. Okay, this is something I would love to explore. Has somebody written a wrapper? Theoretically, it should be possible because the architecture of Spark is such that you can interact with it using any programming language. And yeah, so any Java objects can be accessed via JavaScript, and therefore it should be possible. There must be some client that is written for JavaScript for this as well. All right, now a bigger question that comes is why Apache Spark, or why is Apache Spark faster than MapReduce? These are the two questions that come often. So here is a very simple pictorial view. So basically also it's not about Scala versus Java, right? It's not about Scala versus Java because Apache Spark is faster than MapReduce, not because Apache Spark was written in Scala and MapReduce was written in Java. No, there are insignificant differences. Those are non-significant differences, right, between Java and Scala. In-memory processing is one of the main reasons. Thank you, Mohammed. So here is an example use case. There are actually multiple reasons. One of the reasons is this. Imagine that you are using Hadoop MapReduce. Okay, you are the user on this side, you want to process some data, and your data is lying in HDFS. So you will write your MapReduce code, send it to the MapReduce framework, and it will first read the data from HDFS, and it will write the output to HDFS, correct? That's what we did as part of MapReduce. You remember our word count that we did, where we read the data from HDFS and saved it back to the HDFS, right? Now, this was fine, but if you have a little complex processing, imagine that in word count example, if we wanted to just pick top 20 most frequent words, then we will need two MapReduce phases. Okay, first MapReduce phase to find the find the frequency of words, and second MapReduce phase to sort the data based on numbers and then get the results. Now, if you have multiple Hadoop MapReduce, right, multiple phases, what happens is that the first phase will write to HDFS, then second phase will again read from HDFS and write to HDFS. So there are so many trips, and for anything, we have to create these multiple jobs. So two problems with this approach. One, our code is about writing MapReduce job rather than solving our problem. Correct? And second problem with this is that there are multiple trips to the disk. Okay. If we could have just combined both of them together instead of making this trip here, this is an extra trip to HDFS, we could have saved a lot of time, right? We could have saved a lot of time. So that's one of the, this is an architectural difference from the Spark. In case of MapReduce, it was a batch-wise design. Every MapReduce cycle reads from and writes to HDFS, heavy latency. And this converts logic of MapReduce, converting any program to MapReduce paradigm was really difficult. Similarly, MapReduce was designed for really, really humongous data, assuming that that no data can fit in the record, not more than one record. Not more than one record can fit in the memory. That was the sole assumption of MapReduce, and therefore, caching the data or in-memory computing was not possible using the classic MapReduce, right? So it was an architectural difference. In MapReduce design, the idea was that not a single record, not more than a single record can ever be cached or loaded into the memory. Remember our map program? We always get one record at a time as input. We don't get more than one record at a time as input in our map function. Therefore, in-memory computing was really, really difficult, and therefore, the inefficiencies were there in the execution. Though MapReduce programs were stable, using MapReduce, we were able to process hundreds of terabytes of data, but the overall performance was not great, right? So if we, instead of writing to HDFS, if we write it to the memory, it'll become suddenly really faster. It'll become suddenly really faster. So instead of HDFS, if we are doing these phases in the memory, it'll become extremely faster, right? So it'll become more than 100 times faster in case of if we are doing the entire processing in the RAM. So this is an example of the latency numbers that we all should know. So you should take a look at this particular URL. If you want, I can give you the link. Okay, you can. All right. So you could take a look at these numbers. It's very important to know that these numbers say that reading 1 MB data sequentially from SSD is close to 1 millisecond. Seeking the data in SSD is in hard disk is 10 milliseconds, which is 20 times the data center round trip. And reading 1 megabyte data sequentially from disk is 80 times slower than the memory and 20 times slower than the SSD. What is SSD? SSD is solid state drives. Those are the ones that come in your MacBook or your SD card in your phone. That is the one that you have in phone. While the disk HDD, hard disk drive, is something the bigger one, nice version of the floppy, but very stable versions, right? It has a magnetic disk in which rotates, and you have a header which reads the data. So there is a mechanical movement in your hard disk. Mostly the desktop computers which have a bigger space, they generally have hard disk. The hard disks are a bit slower, as in 20 times slower than the solid state drive, but they are cheaper and available in larger sizes. Okay, so here you can see that data, if we are sending one data packet from CA, the California, to Netherlands and back, it takes close to 150 milliseconds. So this network transport is probably the slowest process. Okay, it is 8 times slower than reading the data, reading 1 MB data from here. Okay, a question from Grishma is, computing is in the RAM. If computing is in RAM, then more memory is needed, and if that data is huge, then it won't let other processes to run. Correct? So RAM means, yes, very good point. Very good point. So if we are doing the computation RAM, and that's exactly the reason why MapReduce never used RAM. So if we are utilizing RAM, what happens is that your program will basically choke other programs and it will not let any other programs run. Also, RAM is smaller in size. Generally, you have RAMs between say 8 gigabytes up to say 64 gigabytes or maybe more. On an average, you don't have more than say 128 GB RAM. Okay, but there are systems where we have had like 200 gigabytes RAM in some of the servers, but you on an average you don't go beyond say 128 GB RAM. All right. Now coming back to it, so when you have so RAM is a big bottleneck. Probably that's the first bottleneck. When you are building any application, it's not the CPU that becomes a bottleneck. It is the RAM that becomes the bottleneck. And though RAM is extremely faster, it's the costliest storage. And if you shut down the computer or something crashes, whatever is written in the RAM disappears. So those are the downsides of RAM. Therefore, you always have to make this decision between how much data to keep in the RAM and how much at a time we want to read. Okay, so we can't really do entirely in memory processing. Therefore, we use multiple computers to retain the data in the RAM. So yes, so it is basically we use the RAM on multiple computers parallelly, and we are very particular about it. And what you will understand is from rest of the discussion, it's always the way we are writing the programs. Like for example, in RDD, we are creating a record. The record must fit into the memory and so on. Okay, so the whole game is about understanding the behavior of RAM and how to optimize it to fit our business requirements. Okay, and that's a very important part. So we basically do the trade-off between interacting with RAM, interacting with the disk, interacting with the network, and interacting with the hard disk. So that's what those are the various trade-offs we play with to get our work done. All right. So so we try to make our work distributed as much as possible. Okay. We try to work through that. All right, so let's take an example, a very simple example. So one of the students, right, from the team, what he did was he basically created a file by by printing the same string again and again into a file. Okay, and the whole file of couple of GBs, like around 3 GB or so, the whole file had a single line. It has no new lines in it. Okay, the file did not have a single new line in it, and no matter what framework did we use, there was always a memory overflow. So it looked very strange that we have 2 GB file and we are not able to use Hadoop for processing. The reason was the definition of record in the default settings is single line equals one record, right? And here the single line is equal to few gigabytes, right? And hence it was trying to load, Hadoop MapReduce was trying to load it into the memory and was overflowing all the time. right? So basically, it's always this trade-off, this always trying to figure out how to break our data into records so that we can achieve our objective. And how do we process that? So that'll come more naturally when we solve the problems. Okay. All right. A question from Grishma is that, I mean, if data is like Facebook data, how will be handling that? Okay, I'll actually give you a simpler example, the example that I have handled so far. So let's take a case of the kind of data we were processing at InMobi. So at InMobi, I'll give you a good example. So at InMobi, we were using classic MapReduce. Okay. So we had 200 terabytes of Apache server logs, right? And we wanted to clean this data. We wanted to delete the lines which did not have meaningful results. And we wanted to convert this into which user ID is visiting which products, and how many times. This is what we wanted to get out of the server logs. Okay, so it was 200 terabyte data. It was impossible to load it or tackle this in any other way. So we wrote the MapReduce code whereby the each line, so the input to, can I just use a sketch and that'll be easier. Okay, so here I'll just give you a pictorial representation of what goes on. So this was our 200 terabyte data. Okay, this is very important concept. So I would, because this is what we are going to do. So this is our 200 terabyte data. It basically are just too many files. Okay, so what we did was for bunch of lines, for each bunch of lines, we basically wrote our MapReduce code, okay, in which each line was the input. For our code, each line, let's say, just decrease the line size, each line was a input. Okay, imagine that there was single file of 200 terabyte for now. Okay, and this is basically going through our code, right? Each one is being processed like this, and being, whether it should go ahead or not go ahead was decided here. Okay, whether it want to save the data to the result to the disk or not, it was decided by our code. This is our mapper code. Okay, so basically by writing our MapReduce code, we basically wrote either filtering of the record and so on. So after this phase, when we filtered the data, we were left with a smaller set of data. Okay, where a smaller set around say 20 gigabytes. Okay, then we further cleaned up, as in we in the reduce phase, we further wrote some more cleaning code, and there was more like we counted the repeated ones, and that way it further was reduced to something like 5 gigabytes. Okay, 5 gigabytes. It came in the format where we had the user ID, only the ID, product ID, and how many widgets. Okay, this is the kind of data. From the raw logs, we were able to bring it down to this. And then again, 5 gigabyte was still huge for this. So again, we use the library like the recommender provided by Mahat. Instead of that, we could have actually used the Spark as of today, the MLlib. This is equivalent of MLlib. This, okay. So what I'm trying to describe is that individual line was few kilobytes, right? This was say 200 kilobytes. So for each kilobyte of data, this code was executed. Some of this was on one machine, some of this was on another machine, and so on. So you can see that Instead of we worrying about how to distribute the code, we wrote our code such that we run the code against every line. Okay, so that was an important decision to understand that our data can be processed line wise, right? Line wise, and that's what we did. So this code basically ran on 800 computers. This code ran on 800 computers using multiple cores. Okay. And instead of we worrying about this, we only wrote the code, the mapper code. This is the mapper code, and let the Hadoop do the magic. Okay. So basically, this kind of work is we utilize we first of all break down our data into records, and then we write our code per record, or and then we get the result. So you can see that for individual code, it can of course handle 200 kilobyte. For individual piece of code, the it can always load 200 kilobyte and get the work done, but it can't really load the entire 200 terabytes. Imagine that if there was no new line between these lines, the whole 200 terabytes being a single line, then none of the code will be able to handle it. Therefore, it is important to break down the input data into number of records, into set of records, and against every record, we do the programming and we get the results. Okay, and that's the core idea behind Spark as well, that we are going to break down our input data into records, and we call the bunch of records as RDD. Okay, how to break down? We have various kinds of file formats. One is text input format, other is fixed file format, other is XML format, JSON format. Those are the things that have been written for us. A question from Raju: how long it took to process 200 TB into GB? Actually, this whole processing, including this, took us around. Actually, it used to take a day or so. Okay, a day or so to get the results out of Mahat's. Mahat used to give us the recommendations. Now the same work is replaced with MLlib. Okay, Mahat is basically a bunch of libraries, a bunch of machine learning libraries, which have basically somebody else has written the algorithms for you to give the recommendations and do all complex processing. That's Mahat. Mahat is just a bunch of libraries similar to MLlib. MLlib is far more sophisticated than Mahat. Mahat was a very simple collection of functions, and in case of MLlib, it also provides you data structures so that you can create your own functions and libraries as well. All right, so I hope this discussion was useful. A question from Robin is basically what processes are we doing here? So this is our, say, logs, server log. What is server log? Whenever something a server is serving to somebody, it's actually reading the data from the logs. Sorry, it is writing the data to the logs. Anything the server does, it writes to the log. Like for example, let's say you are visiting Amazon.com, right? Amazon.com will write to the server logs that you visited this product at this time. Correct? That is server logs. Now, if we want to find out that what are the products that you really liked out of your visits. So we will say user ID, product ID, and how many visits, right? And in the server logs, there'll be a lot of other messages, this error, that error, and like non-product pages as well. So we were removing those ones, and we were actually focusing on only few geographies instead of all geographies. That's what the processing we were doing here. Okay, so a question from Alok is, breakdown is done also by Hadoop? Yes, we were doing it using the Hadoop MapReduce. We did not write the Spark, but using Spark, I can visualize that it would have been really faster and easier.
Sandeep, one question.
Yes, go ahead.
Yeah, 200 terabyte is you divided into 200 KBs, correct?
Each line was anyway in the KBs.
Yeah. So
Mhm.
on each 200 KB, you apply the code.
Yes, the mapper function runs against every line.
So there are a lot of mappers.
We wrote only once. We gave it to Hadoop. Hadoop executed those mappers, cloned the code on all the machines, and ran it parallelly.
Mapper and reducer will be the like same instance.
No, they'll be separate. So basically, we write the two pieces of code, mapper and reducer, in case of Hadoop, and we gave it to Hadoop that, hey, can you execute this nearer to the data? So Hadoop will basically run your pieces of code parallelly on all the machines without you having to worry about cloning.
So why not one code will run? One code will not sufficient for all.
No, it's the same code, just that it has to be copied and carried
Okay.
to all the machines.
Calling again and again.
Correct, correct. That's
So
better way to
it's
say.
a overload on machines.
Yes, yes. Calling basically distributing the work to all the machine, because for distributing you have to take the code, go to all the machines and instantiate it. After instantiating, you have to run particular function. All of that work was done by Hadoop for you. You just wrote one piece of code.
It is map reducer structure, correct?
This is MapReduce only.
Okay.
All right.
So
Good
what are
question.
the disadvantage?
Here,
Yeah.
so see, here I was saying you, right? So there are two parts. One, we were filtering the data, and in second, we were aggregating. So first filter, second filter. So there are two jobs. There were multiple jobs actually happening here. Okay. So for between each job, the data was being saved again and again to HDFS and read from the HDFS. And that made it the entire process slower. This can be made really faster using Spark. So if you have complex work, right? If you have complex work and you would like to first, let's say, just clean up the data and then aggregate in the next phase. So you will end up making multiple trips to the HDFS, right? So here, this is an HDFS and it's being, this particular job is just writing to HDFS. The other job is reading from HDFS. So this trip is something that can be avoided using Spark. All right.
Can you again repeat what is the advantage of Spark?
Yeah. So you see this process here is first MapReduce job, second MapReduce job is here, right? So this MapReduce job is writing to this HDFS folder, and this MapReduce job here, right? Here is basically a MapReduce job, which is taking this data and converting into this one. So in this one, it is going to write to HDFS, correct? In this one. Similarly, this is going to read from HDFS. So this trip is extra, right? If basically this directly would have given data to this one instead of writing to HDFS, it could have been better.
So how Spark will do it directly?
Yeah, so Spark has mechanisms of partial caching and things like that. So instead of the trips to HDFS, it can directly feed that. We'll learn that part as part of this session. Okay.
Okay.
So remember that whenever we write MapReduce job, we define input folder and output folder. So and each job can only have one mapper phase and one reducer phase. If you have two reducer phases, you can't really have a single job. You have to have two jobs. So those kind of optimizations are done by Spark, and we will learn those parts today. A question from Robin is, these are very interesting questions, and right, and when you are going for your first interview, probably these are the questions the interviewer is going to ask you. All right. The question from Robin is, in actual Amazon production, for instance, where can we find Hadoop as the component helping on the MapReduce process, which you discussed? In actual Amazon production, for instance, where can we find Hadoop as a component helping on MapReduce process, as I discussed? So there is something called AWS MapReduce, That one actually gives you the access to MapReduce. Okay. So this one, in our case, it was basically our own cluster in which we were doing the magic. All right. A question from Hitendra. In-memory process would require large RAM. What is typical RAM requirements in Spark environment? A very good question, Hitendra. So question is that here it looks like everything is in the RAM. So that means that is Spark going to need more and more RAM? The answer is no. Okay, so Spark basically carefully uses the RAM. It always uses the total of 60% of the RAM provided to it. So we can specify that Spark application should not go beyond this memory. So Spark will basically would not go beyond that memory. Okay, if you increase the memory, then it'll be faster, and hence it'll basically do the job faster. So essentially, whether you increase the RAM or increase the number of machines, in both the cases, Spark is going to scale up, okay, automatically utilize whatever it is. It is up to us based on what requirements do we have that we should do that. All right, good question. Was I able to answer, Hitendra? A question from Mohammed is, can we please do a job in both MapReduce and Spark to better understand? Sure. We'll do that. And yes, we will try to see if we can compare, or maybe we can do a proper comparison with bigger data. So let me prepare this. This is a good exercise to do. Or if any of you wants to do this for the session, that have some kind of have some little bigger data for word count. Okay, have some bigger data for word count, maybe say 10 gigabytes kind of data, and I'll let you upload it. Or maybe we have a bit better data. We have a data set with how many machines? It is 8 gigabyte. I think that will be good enough for experimentation. So we will do that using that. Okay. Let's come up with one problem statement, and then we will experiment with that. So it's going to, this one has 8 gigabyte is how much? 8 into 8, right? So around 64 tasks. Okay, 64 what blocks, data blocks in HDFS. So yeah, that's going to basically for each block mostly we'll run one job and it'll happen. So I think that'll be good enough. So let's do this one using both. Okay, great, wonderful. All right, so just remind me once we are through this session, then please remind me. Great set of questions, and these questions are something that we all must pay attention to and try to answer ourselves, and then it'll make more sense to get an answer from me. All right, so first, the Spark already is installed on CloudxLab, but let's say the scenario is, so let's get started here. We have talked about this, and this is an example, and there was one more question which I missed. I'm getting a feeling. Yeah, a question from Hitendra. What is Apache NiFi? NiFi is again a processing environment. We can discuss it probably at a later point. Okay, so question from Spark. Question from Sachin is, how Spark take little RAM? It'll basically utilize. Okay, question from Sachin is, how Spark takes little RAM? Spark basically utilizes whatever RAM is available to the process. So while you are defining your cluster, you generally define that individual programs should not take more than this much memory. Okay, should not take more than this much memory. We call that as container size, right? And based on that, number of containers are decided on each machine. And Spark does not consume more memory than given to the container. So whatever memory is available to the container, it utilizes 60% of that, right? So instead of trying to load more records on one machine, it will load lesser number of records into the memory. So that's the trade-off it does. So whatever is kind of memory available to it, it will basically load only that amount of data into the memory while keeping rest of it into the disk. That's how it basically tune the it basically tries to optimize upon the memory consumption. Question from Prashant. Not sure if it is the right question, but just wondering that 1 GB data on HDFS is equal to 1 GB data on the RAM. Sometimes no, sometimes no, because when you are loading the data, let's take case of hash table, right? A hash table is nothing but key value pairs. So whatever is the actual data, a hash table in the memory takes around 4 times the memory. It's about the data structure. It's about the object. All right, good question. So 1 GB of hash table or key value pairs would take around 4 GB of the RAM. All right. Specifically, this I have calibrated in case of Python. Maybe in case of Java, it might be taking a little less. All right, very good questions. So now going ahead with the rest of the discussion. So we've
Sandeep,
already, yeah.
I still don't understand.
Mhm.
For example, if Spark, and there are a lot of load on the Spark, then it needs a higher RAM. Na? How can it take into lower RAM?
Right. So that's what I was discussing. So basically, the input data. So whenever we are talking about Spark, we always talk about the array, and you will actually learn it the way because the way we have always seen the work is there is data. Let's load entire data and process it, right? That's not how it works in case of say Spark. We tell Spark that hey, here is the data and this is my code. Run this code on the data. Now it is up to Spark whether to load all of the data into the memory or to load only some of the data. Now how to differentiate between some data or all of the data? That's why we define something called a record. Like we have a huge file, say 500 GB data, and we say that our one record means one line, right? In that case, one line will be loaded into the memory. In the worst case scenario, only one line will be loaded and your code will be applied. So we will have to write the code in such a way that it requires only one record at a time. And the record definition and the way we code is something that we always tweak. Let's take a case of, say, our data is in a tabular structure. Okay, I think that will be easier to define. Imagine that we have our data in tabular structure. So we have, let's say, this kind of table, right? And we write our code in the format saying where column 1 equals 10, right? How many record, if we have to run this program, how many record at a time it would require? Select, so imagine that we are writing select star from my data. My data is in the form of a table. Okay, let's just think about the database for a moment. So if we are having this data in the table and we are writing a query like this, in worst case scenario, how many records are needed at a time in the memory? Anybody? In the worst case time, one record, right? So this condition will be executed on first row, second row, and so on. Now, if the memory was more available, instead of reading one record at a time, we could read more record at a time and apply this query. So it'll become little faster, because in case of in case of any drive, or in case of reading from file, if you read a huge chunk of data in one shot, it is little faster. It's faster than reading one record at a time. Okay, so you can see that um, in this case, in this example, since our data was in the form of rows, row 1, row 2, row 3, and so on, we were able to, we can actually process the data with the memory equal to the size of the row. Okay, that's exactly what Spark also does. We define the records. We say that, hey, this is my huge data, but this data is made up of these kind of records, and each record is in this format. So Spark will use its judgment that how many records can it load at a time. Okay, does it make sense now? No?
So it will be through machine learning or
No, it's actually simple program, right? So let's say you are writing a C programs. Let's think about this. Let's think about this. Right? Let's say you are writing a simple basic program. What it does is it has to find out whether column equals 10, right? So what will you do? You will start writing this file, reading this file from left to right. The moment you hit the new line, you will consider that, okay, my first record is here. I'll run this record against this logic, and then we'll put it in the output file. Then we'll read the another file, then another record, and another record. Now, in this case, we are just loading one record at a time. That is making it really faster, really using the low memory. But this is not efficient. This is not efficient, correct? So if let's say you are writing a C program, very simple program. So you are saying um, read say 100 characters, or read line till new. Okay, so we are saying line equals read line. What it'll do, it'll read the characters till it hits the new line. Then it'll say, okay, does line we'll split the line based on something, and it'll say line say 0th is equals to 10. Okay, then if this is true, then we save it somewhere, we write to the disk. Okay, otherwise we skip it. So what's happening is here, okay, I'll just describe again. So I'll say write the line in some other output. So okay, so what's happening is that we are only processing, how much data are we loading at one time in the memory? How much data are we loading in this program in the memory? One record, right? Only one line, correct? So we come up with the idea that, hey, this is not efficient because it's becoming really slow and it's not working well, right? So you come up with another design. Okay, you come up with another cool design. So is this design clear to you? What is it that we're trying to achieve here? Okay, let's say we have a huge data and we want to only select the records or lines in which the first column's value is 10. And this data is separated by maybe tab or space or whatever. Okay, no? So we are writing a really simple program like in Python to do this filtering of the rows, right? Should I repeat this part?
yeah, if so we have to write one record only, correct?
So we are recording, so this one is going in an infinite loop. Okay, we are saying while while line not equal to say end of file. Okay, so we are basically doing it in an infinite loop for the whole file. You see that? So we have just written a statement which basically I'm just writing a pseudo language for now. So we are saying go, keep on reading the data from the file, read one line at a time check if it is there, if it has 10 in this line, and write to the line. So how much memory do you think it consumes, this program? How much memory would it consume? It'll consume one record at a time, size of one record, right? Because that line is being overwritten. This memory is being overwritten as and when we are reading a new line, correct? So we are saying keep on reading the data from this file, right? Keep on reading the data from this file, and if the first column in the line is 10, then save it to another file. Let's say write to file 2. We have, imagine that we have file 2 dot write. Okay, so how much memory are we using here? One record. Thank you, Mohammed. Sachin, does it make sense?
Yeah.
One line only, right? Now
Yeah.
we realized that, hey, this is not efficient. Let's create another program which, based on the memory available, will load number of records. Correct? So we could come up with a newer design in which it will first check how much memory is available. Accordingly, it will load the number of lines in the memory. Okay, and then process that. Okay, yeah. So so we will basically create some kind of a batch and would read it. So those kind of optimizations could be done, and that's what Spark does. That, hey, we have sufficient memory to, it'll keep on reading the data from the disk into the memory till the point whatever memory we has allocated to Spark, it fits in there, and then parallelly it will start processing the data using this kind of a logic. Okay, so here we are only loading one line at a time. We could load like read lines, and we could pass say um, read lines until the memory is hit, or we could create something called a buffer in between, that there is a buffer like a big array in which one program is loading the data, another program is processing the data, right? Okay, was he able to explain?
Yes, Sandeep.
Okay, great. Great set of questions. So, all right. So essentially, what basically this is where lot of optimization comes into play. So here, the example that we were taking is that we want to filter the records. Let's say we want to filter the records, keep only the records in which first column is 10. One way is really simple. Just read the line, check if the first column is 0 or not, and the first column is 10 or not, and then save it. That's the simplest one. But this one is little slower because while there are multiple issues with it. One, while we are reading the data from the disk, this logic is waiting, right? So this could be parallelized, right? The other problem is that it is not utilizing the fact that when we are reading data from disk, it's actually better to read multiple records in a single shot instead of reading one record at a time. So those are the two things that these frameworks help us. Along with that, let's say this file is spread across multiple machines. So can we run this same logic on multiple machines and get the work done parallelly using multiple machines? So those are the values added by frameworks like Spark. Okay. All right. So a question from Hitendra is, looks like Spark has employed various computer science efficiencies methods such as hashing, key value, data compression in-memory architecture to achieve faster processing. That's right. Thank you, Hitendra. So yes, those are the optimizations done. A question from Robin is, please elaborate more where container size comes in. What is the best practice in allocating the container size? It is more related to memory or storage or both. Is container inside HDFS? So container is inside something called yarn, and container size generally we keep it as 1 GB, which means that if your individual program or individual code is taking more than 1 GB, it is going to fail. Okay, so okay, we'll talk about yarn after this, and then you will get the picture. Okay, we'll do a
Only
brief
we can
recap.
check the memory also. We have to write the program for checking memory.
No, so memory is generally passed as argument, and you can just check the environment variable. So you don't have to, because Spark does it. Spark basically checks how much memory is available, and accordingly, it optimizes number of records it would load in the memory.
Okay. And if
Okay.
the remaining, then it will be discarded.
No, they will be basically in the, it'll do it in sequence then. Let's say it'll pick up 3 records first, then another 3 records, then another 3 records, and so on. They'll keep it in the disk. Let's say there are 500 records. If in memory it can only, based on parameters provided to Spark, it can only fit in say 3 records. So it'll first pick the 3 records, run your code, then another 3 record, run your code, and so on. If the memory is more available than maybe for 20 records, so it'll pick up 20 record first, the next 20 records, then next 20 records. So based on memory available, it will pick the number of records. Okay.
So in MapReduce, how it was there? Like if there are more records and then memory is full, then that is discarded.
No, in case of MapReduce, it was assumed that not more than 1 record will be loaded at a time. So there were multiple tasks. They will basically load the 1 record at a time and run the mapper code.
Decide, we have to decide previously in MapReduce.
No, in case of MapReduce, it was decided that it will only process 1 record at a time. It'll load only 1 record at a time.
Okay.
Okay, but on multiple machines and multiple threads. Okay. In this case, it basically optimizes on the memory and sees, okay, more memory is available. Let's load more records instead of, while MapReduce's design was that, hey, we are not supposed to touch more than 1 record at a time. Otherwise, there will be an overflow. That was the kind of design, that was kind of thought process we had.
So in MapReduce, compulsory 1 record only.
Internally, yes, that was the core of their design.
Okay.
Okay.
Okay. Yeah.
So at one fraction of second, that was the one moment, only 1 record will be loaded, not more than that. Though there were multiple tasks for same program, there were multiple tasks and multiple tasks executing parallelly. So they will all load one record each parallelly on multiple places. Okay. In this case, it tries to optimize on how many records it can load and based on the memory available. Okay, so that is one of the big differences between the architecture of Hadoop and Spark. All right, now, okay, a question from Grishma. So for line.split, what is the delimiter used? I mean /t or space? Yeah, by default, in this case, we assume that it was space. Okay, that was the example we were taking. A question from Mohammed, how is the synchronization on accessing the file done? Good question, good question. So basically, it's read-only access of the data. It's a read-only access of the data. Therefore, we never modify the same file which we are reading. And hence, there is no problem of dirty writes or things like that. So is that your question? It's a good question. So another question from Hitendra is, container is more related to code than data. So container is all about executing your logic, and container is more like a JVM, Java Virtual Machine, in which you run the program. Yes, we need to run a sample to clearly understand the difference is crystal clear. Correct, correct. That's why I would like to move ahead to do the hands-on. Okay. So great. Let's take a break for 10 minutes, or do you want a 15 minutes break? A question from Grishma is that hope will have more hands-on than theory. That's right. That's right. And a question from Mohammed is, if one same file is accessed by multiple machine, how is that synced together? Good question. Good question. So generally, the data that we talk about in case of Spark, what happens is data is already spread on, say, HDFS or any distributed file system. So individual machines access the individual part, and actually the logic is executed nearer to the data. All right, so individual parts are parallelly loaded, like each data block will be parallelly processed on multiple machines. Remember that in HDFS, data is located in parts. Every file is broken into smaller chunks, and these chunks are distributed on multiple machines, along with each block having 3 copies, right? So so when we are doing the processing on top of HDFS, the number of total tasks are generally equal to the data blocks. Okay, so each block is processed by one machine. So that way, the synchronization happen. The only communication between the two nodes happen is in the border condition. Imagine that there was an extra line on the border, as in half of the line is in one data block, half of the line is in another data block. So the second half is transmitted to the first node, and that's how it happens. So only that communication happens. Okay, so let's start. We will go into more details. You will see that more involving examples. And right, so we have already installed Spark on CloudxLab. You don't have to install anything. You can simply log in to Web Console either via Jupyter, SSH, or simply the Web Console. So we are going to get started with the commands. In case, let's say you are setting up in your organization, there are, let's say you want your own instance, you can simply go to Apache Spark and download the latest version along with pre-built, say, either Hadoop 2.6 or so, and you can just run it locally. Okay, you can just run everything locally. Also, in case, let's say you have a server, you are in your organization and your organization says that, hey, we have Hadoop cluster already, but we don't have Spark. So what you can do is just find out the version of Hadoop that your organization has. Then let's say your organization is still having 2.4. Then you will go to Spark Apache download, and then select the revision with say 2.4 here, and then basically click on download, and instead of that, just copy the URL of the download file and use the wget to download that on your server, because on server you can't access the browser. Therefore, you just copy the URL of the download file and use wget. Wget is a command with which you can download any URL. Okay, once you have downloaded it, you can run it with Hadoop after extracting. Okay, so you don't have to install as such. You can just unzip it and then start using it. Okay, it's extremely simple. So all right, so any downloads has a folder called bin in which there are Spark commands that you can run. All right, so these are the Spark commands. You can use Spark Shell, PySpark, SparkR, or Spark Submit, or Spark SQL. These are the various programs that you can use to interactively process data. A question from Alok is it mandatory to have same version of Hadoop in Spark? No, actually you have to download Spark's version for your Hadoop. Let's say in your organization, you are using 2.3. So go to Spark, download the Spark's compiled version for Hadoop 2.3. Okay, because there are different versions. So same version of Spark is available as pre-compiled binary for different Hadoops. Okay, it's like saying that I'm downloading Windows 7, but this is 32-bit, this is 64-bit. In the same way, we are downloading Spark, same version of Spark, but for different bindings with Hadoop's versions. All right. So here we are downloading Spark 1.5. We can either download the version which is pre-built for 2.3, 2.4, 2.6, or the source code. Okay. Good, great question. Now moving ahead. So here we have these basic commands. So we are going to use these commands. Spark Shell is the first command. Spark Shell is for running Scala interactive command lines. PySpark is to run Python Spark interactive command lines, and Spark R is to run R on the Spark. Okay, and then we have Spark Submit, Spark SQL. So by default, we could just go here and let me switch to the console. So here we could say Spark Shell, and this will launch the older version of what's happening here. It says invalid something. I have never seen it before. Bin HDP select. Okay, missing parenthesis in the call. Oh, I see. This is right. Yeah. So I think I'll just instead of this, I'll just use the normal console. Okay, I'm going to use the normal console because that console is having the newer version of Python. Okay, a question from Mohammed is HDP Sandbox is built into CloudxLab. Actually, the CloudxLab is having the entire environment. So you can actually take a look at, it's not a sandbox, it's a full-blown Hadoop installation. So it has around 6-7 nodes from A to G. A to G, it has G as in God. So it has those many servers. So it has the complete full-blown infrastructure for Hadoop. Okay, so it's a shared environment, just like we all are working in a company and we are trying to build a POC or trying to solve a problem. It's the same kind of environment. So it's a shared environment, and this is something very useful for everybody to do hands-on, because there are many ideas that you will get as you do something on the cluster. Okay, because in the local cluster what happens is we all get under this illusion that our program is working. Okay, because in the local machine there is no memory constraints and there are no disk constraint. So we end up running everything on local machine, and then we come to the cluster, or we put our programs in production and say, and when it gets killed in the production, it is not run, then you say that the life is unfair and it's not running, right? The reason is that in the cluster, in the cluster, there are memory constraints in any cluster. Okay, my first program, which was processing 200 terabyte data, it was thrown out of the cluster when we launched it for the first time, because it was consuming 4 gigabyte of memory while only 200 MB on each node was allowed, right? So basically that was first realization that we must test things in a cluster instead of assuming that everything works great locally. Okay, so it's important for all of us that we work on the cluster instead of local installation. Okay, so I'm logged into this Spark Shell. Sorry, I'm logged into the console and I can launch this Spark by Spark Shell. Okay, a question from, okay, a question from Bharti Raja is that login is incorrect. All right. So probably try typing the password or try copy pasting again. Please remember that while we log in into Web Console, the password will not echo on the screen. It will not even display an asterisk. Okay, so you will feel that it's not being typed, but it's being typed. Okay, so that's how in Unix is that when you are typing the password, it doesn't show anything. Okay, so I'll just decrease the window size a bit so that it is visible to us. All right, great. Now, there are a few questions again I missed. So a question from Mohammed is HDP Sandbox is built into CloudX. Okay, this one is answered. And Ambari is a UI by Hortonworks. That's correct. While Hue that you see is by Cloudera. So we have taken the components from both the sides and created a singular environment in which you can use any of the components. Also, in the same cluster, you have access to other programming languages as well as other programming frameworks. So whether you are trying to do machine learning along with Spark, or you're trying to do, say, big data analysis along with, say, Hadoop, so you can do all kinds of permutations as per your choice. Okay, so you can right. So instead of segregating the technology landscape, we have a single cluster with the whole environment ready so that we can do all kinds of permutations and build all kind of projects. All right, so Ambari is for mostly admins and Hue is for more coders. That's correct, Hitendra? Okay, what is the equivalent of Ambari in Amazon's cloud ecosystem? So Amazon has their own UI for managing the cloud. Okay. So does always Spark shell lands into Scala environment? That's right. That's right. All right. So Spark shell is nothing but Scala environment. Here we can write our Scala programs. So like, for example, this is the most simple program I could write. 2 plus 3 equals 5. Right. So this is here we can write our programs, uh, just standard Scala programs. Just that it has few more extra variables. Like one variable is SC. SC is your gateway to Spark context. Is Spark. So SC is Spark context, your gateway to Spark. So Scala prompt is for is having one extra variable called SC. Scala prompt is having one more extra variable in as SC. If you launch normal Scala, let's say I exit here and say Scala, right? Here the SC won't be there. Okay, it says SC not found. So that's the difference between Spark shell and SC, Scala, because Spark shell is equivalent to Scala plus the SC object. SC is your gateway. So here you can write any Scala project, but you can't interact with Spark. Okay, though there are ways in which you can import Spark and start the Spark, there are ways that we will discuss. Okay, so here Spark shell is essentially Scala shell. Scala also provides shell like Python, and these interactive environment are also called REPL, read, evaluate, print loops, in which it reads the logic from you and then executes it and then print the result to you. So these are interactive environments, and interactive environments are really useful for coding or interactively dealing with the data. Okay, specifically in analytics world or in data engineering world, we basically do a lot of incremental programming. We basically write an expression, see if it's working or not, and then we write the function and so on. Okay, so great. So is everybody able to start the Scala prompt? All right. Should we start working on first word count example? Should we right away do that? Okay. Mm, a question from Binta is that the dir or help do not work under Scala. That's right. So they have their, you can just press dot and press tab. You can see all the objects, all the functions available to you, okay, by pressing tab. And I'm not sure if they have other way of documentation. It doesn't have other way of documentation. All right. So, all right. So should we do a quick word count example? All right. So is everyone logged into the console? All of you?
Sandeep,
Yes.
still one question, like MapReduce in at any particular time process one record, correct?
It will load one record in the memory at one particular time.
And one particular time. And Spark will do according to the memory, according to the RAM
Correct.
available.
Yeah.
Okay.
Okay. All
Mm.
right. Should we start with the console? Are you logged in into the console? Okay. So by doing the hands-on, what happens is subconsciously we build up the concepts, and those are more stable way of learning than the theoretical way. So I would strongly recommend everyone to do hands-on, because a lot of ideas you will form by yourself without even learning from anywhere. Okay, that'll come naturally. So one of the things that I have experimented and has worked well is doing the hands-on before the theory. And that sounds very strange, but it does work out pretty well. Okay. One of the things that we experimented with in the machine learning course was starting with just the hands-on instead of talking about theory of machine learning, and it worked pretty well. Okay. So I would request all of you to come over and let's start doing some hands-on. Okay. So is everybody logged in into Web Console? And then after Web Console, just launch this command called Spark Shell. Okay. Alok, it might try. So what it does is when we launch Spark Shell, it's going to initiate a local service, okay, at a particular port called 4040. That's a UI to display something, right? So you see that? Okay, so Mohammed is not able to log in using the credentials. Okay, okay. So let me just um, see which console is it showing? What is the URL in the console, Mohammed? Is it e.cloudxlab, f.cloudxlab? Okay, no, not this one. Go to my lab, go to my lab, click on Web Console, okay, and then copy paste the password. Go to my lab here. It'll show you the lab credentials, login and password. You click on Web Console and then copy paste this login and this password. Okay, so open cloudxlab.com, okay, and go to my lab. Okay, so are you able to log in now? Okay, so everybody here, so what's happening here is if you let me just scroll up. let me just scroll up. It's basically an older version that comes by default with Hortonworks, though we have added more versions, and those are newer versions are available now. We'll talk about those versions very soon. So locally, when we are launching Spark shell, it's starting the Scala shell, and it is basically starting a local web server for you. So for everybody, it's starting a local web server so that we can visualize the graph of objects. Okay, so it's called the Spark UI. It's starting the Spark UI locally. For that, it's trying to find a port available. So it starts with 4040. It starts trying 4040. Then it tries 4041, 4042, 4043, and so on. And then finally, it's able to start the service. Okay, so basically behind the scenes, where we are launching the when we are launching the Scala, it's actually starting the Spark driver on your side. Okay, this is starting the Spark connection with your site. So here the entry point is SC. You can put dot and press tab twice, and you will see the various commands available. Okay, various commands available. All right, I'm not sure how to see the documentation here. All right, I'm not sure how to see the documentation. Maybe I'll have to consult the Scala documentation. All right. So if you are able to, when you type SC, if you see this, that means everything is okay and it's working. Good. So what we are going to do is, okay, a question from Bintao is SC dot also does not work under Scala. That's right. If we are launching normal Scala, the usual Scala, then you will not have this object called SC because the Spark context is not yet initialized. But in Spark shell, this would happen. Okay, a question from Alok. What is the URL for Spark UI? So you can generally find the URL here as you go ahead. Okay, so somebody's video camera got turned on, so you can turn it off. Okay, so all right, let's go up. It would be saying something like successfully started the Spark UI. Okay, so yeah, it says that it has successfully started the Spark UI. Now, since it is on e.cloudxlab and this is a local IP address, so we'll have to access it using e.cloudxlab. Okay, e.cloudxlab. So not really required. We'll talk about this probably at a later point of time. All right. Okay, so it doesn't seem to work. 4045, right? 4045. Yeah, it doesn't seem to be working. So we'll see that later. No worries. Okay, because maybe the firewall is stopping. Okay. A question from Bintao is there a way to get help on a single command in Spark Shell? I'm not sure. I'll have to take a look at the documentation. All right. We'll talk about that in maybe in next session. Now, so we are all up and running with the console. This is where we all are, right? Now is the time that we start loading the text file. Okay, so first of all, we are going to say lines RDD, just be with me. So we are going to ask Spark to load this text file called data mr word count /input, right? So here, if you take a look at, say, Hue, this data, there is a folder called /data. If you go to file browser, so we right now what we are looking at HDFS. In HDFS, we have already put some data in this data folder. Okay, you see that here. So here there's a data folder, and this is the folder that contains our usual MR data, and this big.txt is what we are looking at. Okay, or this is the file. This is the file that's what we are looking at. So, so this is the file that we are planning to load. It's nothing but many books concatenated into one, and we have kept it there so that we can do the word count example quickly. Okay, so let me just load that file. Okay, so we say, also when we are saying loading, it's not really loading into the memory. Okay, it's saying it's not defined, so you have to say where this. Okay, so let me share this code with you. Okay, so all right, all right. So good. All right. So we are able to create this entry point for this data. So this lines RDD is basically representing this file. If you want to take a quick look into this, we can say take 10. Okay, take 10, and it is displaying an array of 10 lines from the file. You can see that here. It is basically displaying data till here. How many lines? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up to here. It must be displaying up to there, right? Do not change or edit the, right? Do not change or edit the. So it's basically displaying 10 lines from the text. Okay, so just to take a look at it, I'm going to just share it with you. Okay, good. So we are able to read the data from this file. Okay, we are able to read the data from this file, and we are able to basically display 10 lines. Correct. Now, the next thing which we are going to do is we're going to convert each line into one word. Okay, how do you do that? Lines RDD dot flat map. Okay, I'll go into individual detail about these functions later. Okay, so you can see that it is there. So we are going to say flat map, and we're just splitting data based on the space. Okay, and we are saying words RDD equals this. Okay, so here let's take a look at the words. Okay, what is there in the words? And we say take 10, give me first 10 words. So you can see the project Gutenberg is what it has written. All right, so we have just converted this into one word per record instead of one line per record. A question from Vinta is there is no outcome from the command of sc dot under Spark shell in the console. No, so you have to press tab twice, then you will be able to see. Okay, so sc dot does basically will not do anything as such, but if you press the tab, it will show you the list of commands. Okay, let's follow through the tutorial. Okay, are you able to execute the tutorials? All right, let me also keep a note in this file here. Okay, so that I can quickly reshare it with all of you. Right? Okay, flat map, what it does is it converts one line into many lines, and our split function provides the how to break it down. Okay, we are going to go into more details as we go forward. So here, this one, when we set 10 lines, it prints 10, this one prints 10 lines here, this one prints 10 words. Okay, so try that out. Now we have the list of words. Now we are going to convert that into the key value pairs. Okay, we can just put key value, and we say this into map, and we are going to say x, return x comma 1. All right, so or we could just say this. All right, so here we are going to say where All right, so let's take a look at this one. Right, take 10 records from this and take a look at how does it look. So it has basically the 10 records in this are the one, project one, Gutenberg one. Okay, so you can think of lines RDD as bunch of records, bunch of lines. Words RDD is bunch of words, like a small, it's like an array of records. And this one is array of key value, where value is one for all and key is the actual word. Okay, all right. So I think the comment character is slash. Okay, comment character is slash. Great. So now let's do something simple, right? We say reduce by key. All right, reduce by key. What reduce by key does is it basically sums up the values. Okay, reduce by key, and these are the word counts. That's all. And you can take a look at, say, word counts and take 10. So let's try to execute this. Okay, and then let's take a look at the word count. Okay, so it has done some kind of word count and it seems to be working fine. All right. Also, if you want to convert it into to lowercase, you could do 2, not like this, 2 lowercase. Okay, so
Sandeep, can you explain these commands? Actually, I
uh,
don't.
right, let's just execute it for now and we will explain it in detail as we go ahead. Okay, try to hypothesize that what does it look like, and then we will go into more details. All right, the idea is to do things upfront and then build a philosophy or build a theory around it. Okay, so all right, here you go. So is it working for you? All right, so I can describe it now, so I think that will help you. So are you able to see the 10 words like this? Okay, no? All right, so I'm going to use save as text file and put it what is the date today? Date today is 25 March, output 25 March, correct? Great, great. So are you able to do it? Then I'll explain.
Sandeep, I have a question here. We have taken that word count dot take and we have
Hmm.
put 10, the numeric value 10. If we don't put anything over there, will it display all the words of a line?
Where?
Word counts dot take in the parenthesis we have put
Right,
numeric.
right. So we must pass some number there, okay? Because we don't see the data. Here we are dealing with huge data, so
Okay.
it's not a good practice to. Although there is another function called collect, which can bring entire data to your console, but that wouldn't make sense, right?
Even in this case of words, rdt dot take in parenthesis you have put 10, right? So
You can
it is
put
this.
100.
Is it like it is working on a line basis because above the variable words RDD is equal to line RDD dot flat map? I did not get it that. I mean, what exactly it did.
Okay, so I'll explain. So
Okay.
yeah,
I
all
thought
right.
it is
So
taking just a
yeah,
single
yeah, yeah,
lines.
yeah. I'll explain.
Okay.
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 All right, is everybody able to execute? It's good to have these questions, and the objective of this exercise was to you all start questioning instead of just waiting for me to explain first. Okay, that's the idea, and this is exactly what I'm looking for. Yeah. All right. All right. So are you able to execute? So Robin is able to execute and get the results. So also you can save the results. You can save the results to HDFS by using a command like this. Okay, this is the last command where we are saving as text file into the HDFS. So you can go to home directory from here. I could click on file browser and it'll take me to my home directory. And since I have too many files, so I will order the data based on the date. And you can see that it has created the output. So you can see that it has part 0. Okay, this is the word count. Do you see that? This is the word count. Although this data is not clean, there are many steps that could be done to make it more sophisticated and meaningful, but is the basic theory. So basic way of getting the word count. All right, now here also. Okay, so you can see that. All right, now here the important part is, even though you always have the programming languages, you have many tools, SQL, Linux, or normal programming to do the same word count, the difference here is that it can handle humongous data. It can handle humongous data. We are using the Scala code, okay? We are using the Scala for programming. Yes. Thank you, David. I've shared the code, the entire snippet for all of you, with all of you. All right. So good, good. So there are quite a few questions all of you are having. Now I'll just go over these and your questions should be answered. All right. Is it making sense to you? This one is working for you. Alvin, Alok, Bharti Raja, Bintao, David, Grishma, Hitendra, Jay, Mohammed, Noor, Prashant, Rajan, Raju, Ravi, Robin, Sachin, Shravanti, Subbu, and Ravi. Yes. All right. Great, great. I'm hoping that it is working with all of them. Now I'm going to walk you through each individual lines. So why did it save in 2 files? That's another question. Okay, so but the list is not the top 10, correct? It's not the top 10, that's right. It's basically, it's just first 10 records. All right, wonderful. So let me just walk you through this code again, and it should make sense to you. First of all, the first step is that we are saying, load this text file or give this text file a name called lines.rdd. We are informing Spark that, hey, we want to load this file. Okay, so Spark is making a note of what we are saying. It's not going to just load the data right now. It just made a note of it. Unless we say take. As soon as we say take, then it's going to go there and load the data. Like, for example, if I make a mistake here, like I type some wrong name of the file, right? If I type the wrong name of the file and run this happily accepts it until we run this. Until we say take, it's not going to do that. Now when we say take, then it gives us an error. So the first line is not really loading the data. It's just making a note of it. It's just making the note of it and saying, hey, yeah, I have accepted your command, but unless you call an action such as take or save, I'm not going to do anything. Okay, I'm going to stand here, wait for your more commands, right? That's what is Spark doing. So Spark basically is creating the plan when you are giving these commands. Next is, we said, okay, fine, you have lines RDD, which contains nothing but which would contain nothing but the lines of the file. Each line will be one record in this lines RDD, because when we say lines RDD.take 10, it's giving us 10 record, which means lines RDD is nothing but an internal representation of an array in which each record is a line. Okay. Next is,
Sandeep, can we give any other name or to the variable also except
of
line?
course, of
Yeah.
course. Yeah. So here we are defining a line. Okay. So you
If it
could
is a file, how can we assign to a variable?
just like we say fopen when we are creating a file. So we create a handle to it. So it's basically a handle that represents the file. Is we call that RDD. So when we say sc.text file is basically creating a internal representation of RDD. We could also say it's simply lines. So it's not necessary to put that. So the core of the Spark revolves around this array representation. All right. Make sense? It's an array representation of the data in which when we say text file, it's going to read the text data such that each line would become one record, one record in this array. Okay, it's an internal representation in Spark called array. So for now, you can just think of it like it's a huge array which can span around on multiple machines. Okay, we're going to go more details. All right. Next is this. Here we are loading. We are splitting the record by space, right? We are saying take each line, execute this logic against each line, and whatever is the result, okay, convert each record, each value in this array, each line will be converted into array, and each array will become a word, right? So we'll go into more details, don't worry. Okay, so here the words RDD would be containing one word per record. All right, next is we convert it into key value, and then we have key value, and then we use reduce by key, and then we save as text file. All right. So a question from Bintao is, does the command sc.text file come out of both? Yes, that's right. Okay, we'll go into more details about each of this. We are going to cover all of this as we are starting with the basics of RDD. We're going to go more details as we go ahead. All right. So words RDD is essentially a variable that internally represents an array. We call that resilient distributed data set. Okay. All right. So should we move ahead? So this was the easiest example of going as in getting up and running. We are going to go individually into more details about this. Okay. Related to, first we are going to, in order to understand this, first we are going to learn Scala. Then we are going to learn, say, the basics of RDD, and then we are going to learn the actions and transformations. These are called actions. Save and take are called actions, and the map and flat map and reduce by key are called transformations. We will go into more details about these functions. Yeah.
Sandeep, how we can get the key value pair?
Here we are converting that into key value pair.
Some algorithm is there or?
No, we are just saying map. Map means execute this particular logic. Okay. So this is essentially saying it's basically here. It means that whatever is the line, okay, return x comma 1. Okay, that's what we are saying. Here, this is the function that we are writing. For every record in the words RDD, what we are doing is we are saying convert it into a comma b. All right. So using map function is like a big for loop. It's going on every record in words and then executing this logic where x is being converted into x comma 1. It's converting it into tuple or tuple. It's called key value pair. All right. We're going to go, don't worry, we are going to go into more details and it'll become far more clearer, right? And once we have created a key value, then we are saying group by. This is reduced by key is essentially equal to group by. And in this, we are saying our aggregation is summation or addition. So just like when we are saying select star from a table and when they say group by, and There we provide an aggregation that we want to do summation. In the same way, we have said underscore plus underscore, meaning add the two values. Okay, that means we want to pass an addition as an argument. All right. Okay, so yes. All right, so if your question is small enough, you please feel free to type in the chat box because there are 21 people in the session. In case everybody mutes, it'll become impossible to handle. Okay, please ask the questions using the chat box, unless your question is bigger, which is difficult to type. All right, great set of questions. So be with me. The idea was to show you that it's so easy to write the MapReduce code that I did not have to keep the code prepared before the class, that I could write during the class. All right. Had it been, say, MapReduce, I would actually use my GitHub repository to show something instead of typing it in the class. All right, that's a very important idea, and trust me, even today, even though I have done quite much work in MapReduce, still, if somebody asks me to write a word count in Java for MapReduce, I'll not be able to do it in the class. It'll take me maybe an hour or so to go through entire steps. So here it is very comfortable. We do the work and interact with the Spark as and when we are working. So we keep on seeing the answer quickly, and that's the idea about the interactive shell. Okay. So our question from Bintao is map this is equal to yes? That's right. Okay, so we are going to go into these details, like how to pass the function to Scala code. Here we are passing the function, we are passing the logic. We are saying that take this piece of logic and run it on all the machines. That's what we are saying here. We are handing over the code. We are handing over the code and saying that, hey, here's my function and run it on all machines. Okay, similarly here and similarly here. So the idea is passing the function as a piece of logic and giving it to Spark to run it. All right. So this is a very simple example. So this one is loading the text data, right? This one is converting the lines RDD into words. Okay. And then this one is converting each word into key value pair, right? Into key value pair. Then here we are saying reducing. Okay, here this is where the word count is happening. This is where the word count is happening, meaning we're grouping the data based on the key, which is individual word, and then for each word we are summing up all the values. Okay, and then saving to the disk. Saving to the disk. Okay, and this is just taking a look at 10 records. Okay, this is just for debugging purposes, and that's it. All right, so that's what it is. Great. So we were able to do the basics. I think I'll go more into details after probably the first session. So let's I hope everybody is able to execute it, and you got the basic idea about right, that this is how the code looks like and this is how it. A question from Minta is, you just load data from HDFS. How about local files? So generally when we are dealing with Spark, we must put the data at such a place which is accessible from all the machines. Okay, therefore even if you have local data, just move it to HDFS or any other central location from which Spark can read. Okay, so if we are going to use the local file, either we move it to all the machines or we basically load it in the HDFS or network file system. Good question. So all right, so that was a little Okay. So a question from Bharti Raja is Spark will run in Edge node? No, you can run it on the whole cluster. Okay, it won't run on only one machine on which you are running the code, but it will run on the whole cluster. Okay, based on what do you say? Based on the configuration. We'll talk about that configuration soon, how to run Spark in cluster mode or local mode. Okay, Spark has multiple modes. One is called local, other is called cluster. And inside cluster, there are multiple modes, and we are going to use all of those as we go ahead. Wonderful set of questions. Question from Robin is, am I right that is the each entire line is described in Scala programs code? Okay. A question, can you repeat the question? So am I right that each entire line as described is the Scala program? Yes, the whole thing, this is a Scala program. That's right, this is a Scala program. So Scala is like Python, that you get an interactive shell where you keep on typing the code and getting the results. Okay, and you can also execute this by using like a script. We can save this in a separate file, and then using the Spark Summit, we can call this. Okay. A question from Grishma is, did we use two reducers? Right now, we did not control that. I think there were two reducers. Yes. All right. We'll go into more details as we go ahead. All right. That's a little advanced question. Good. Good. All right. Should we move ahead? Each new var is new RDD in the memory. Each new var is yes. So here, that's an interesting idea. So here, these are like, representations. It doesn't really load the data. Lines RDD is not consuming any memory, right? And so on. So we'll go into more details about RDD as we go ahead. All right, great set of questions. So we were able to interact with the Spark shell. The difference between where and well cannot be changed, where can be changed. We are going to go into more details. A question from Sachin is, from where is Spark divided? From where part does, okay, is Spark divided? Okay. So here, basically, the data is being loaded line by line, and that's how it is happening. So could you repeat? Yeah, I would love to understand the question. Okay. Why are there two files? Because internally, for whatever reason, it's using two cores, two cores parallelly to get your work done. Okay, that's why it is converted into two parts. So there are two tasks internally doing the work that you have defined here. Okay, so it's happening using two tasks, as you can see here also when we were running the code. So it was saying, okay, let me just show you this. All right, so it was saying that there are two input splits. One is this file and other is this file. Okay, so it has created two input split. Okay, so based on these two input data, as I said, that for our code, it doesn't really matter on how many machines does it run. Internally, it can take a call based on how many tasks are available, and accordingly divide the data and get your work done parallelly using multiple computers. All right. Okay. So I hope I was able to answer the question. Good question. A question from Grishma is, isn't it due to two reducers? I thought, yes, basically it did create two reducers by itself because probably there are two tasks available to it. Therefore, it automatically created the two tasks and got the work done parallelly using that. Okay. A question from Noor is, so Scala code is converted to MapReduce. So it's using its own MapReduce things. It's not using the Hadoop MapReduce. So Scala code is internally executed by Spark, and instead of giving it to MapReduce. Okay. So Spark has similar annotations like MapReduce, but not identical. A question from David: to get a help, type the following line, :help. Thank you so much. So I think that'll be useful for us. Let me see. Okay, so yes, it seems like nice. So I can actually say history. I think we saw it last time, but I forgot. So I can just take a look at my history. And yes, good. Thank you so much. And I had forgotten that. Okay, : help works. So a question from Hitendra is, some key value pairs have two commas because we have not cleaned up the data. We have just splitted the data based on the space, and therefore some of the data is not cleaned up. So we will learn how to clean up. Okay, as we go ahead. We did not do any cleanup. We just split lines by space, and then each word is created. We basically, having one word per column or one word per record, we created a tuple, and then we basically did group by, and that's all. Okay, so we will clean up in this in future, and till then let's move ahead. Okay, so we were successfully able to use Spark Shell, right? That's right, Rajan. After running this command flatmap, it has tuples, right? Is that stored in memory at that point? No. It just is making note that, hey, you want to run flat maps. So it just basically makes note and doesn't really does everything in the memory. Okay, so we'll come back to this as we go ahead. All right, so the idea was to just do a hands-on, and all of these questions that are coming up with you, these are very important questions, and we will go into more details as we go ahead. In Hiten's question is RDD the main concept in Spark? It is the main concept, but this is not the only concept. There are many other things that we will discuss in more details. Okay. Now, similar thing we could also do in PySpark. Similar thing we could do in PySpark. Let me see if I could just convert this into Python. All right, so this is okay. This is okay. This is yes. Okay, this we have to change. We'll have to say x. We'll have to say lambda x and say x dot split. Okay. All right. I'm hoping that this would work. Okay, so this is, so I'll say lambda x comma y and return x plus y. This is our Python code. Let's see if it works. All right, so similarly, if you are interested in Python, you can simply say PySpark in the same way, just like we did Spark Shell. Okay, just like we did Spark Shell, and it's going to launch the Python version of the same thing. Okay, so the same code that we did earlier for Scala, we can write a similar code for Python. Okay, so here I created lines RDD. Let me take a look at it. It's working or not. It seems to be working, yes. And then I'm going to split it. And then we are going to take the records. Yes, it is working fine so far. Then we created the key value pairs. And then we are going to just take a look at the key value pairs. Okay, we're going to take a look at the key value pairs. So let me just create the code. So here we go. So this is the Python version. And here we go. And then we basically, okay, do the word count. Take a look at the word counts. It is working fine or not? Yes, looks like it is working. And then we save it as the another folder. All right, so you can see that here, the difference is // we need to put it Okay, so here is the Python version, those who are interested. Okay, so lambda is basically to define an anonymous function in case of Python, those who are curious. So when you are creating an anonymous function, we create lambda. All right, so this was the Python version. So yes, in case you're interested. So we are able to use PySpark. Yes. So you can see that the Scala and Python versions are not too different. They're just minor differences. Okay, one is with respect to defining a function, other is with respect to the commands. A question from Noor is, what's the difference between Spark 1 and Spark 2? Spark 2 has a little bit more differences, okay? But the concept that we are learning right now are same in both. Spark 2 has data frame, and the entry point in Spark 2 is called Spark, not SC, okay? So it won't be much different. We'll learn about that. So it won't be too much different at all. The parts that we're learning is same in both. All right, so that was Spark 2. Sorry, Spark, PySpark. Yes, are you able to do this PySpark? So again, just like Spark shell, PySpark is nothing but Python shell having extra variable called SC. You can always take a look at the documentation by using dir or help. Okay, so yes, you can use dir and help to see the documentation. All right, and also probably use question mark to see the information. Good. So you can see that there was not much of a difference between the Python version and Scala version, right? So that gives you a bit of comfort that it's not going to be drastically different. Question from Sachin is, which tutorial we need to do for Spark? Either of one, either Scala version or PySpark version, okay? But there's no harm in trying both, all right? You'll become comfortable with both. All right, good, good. Yes, did you get my code, which I copy pasted in the chat? All right. Now the next thing is we can also run a full-fledged program using Spark Summit. Let's say we coded something in Java or in Scala. We compiled it into class or jar. So the way it happens is whether Java or Scala. When we compile it, so I think I'll just give you a very brief here before we jump ahead with this. This might look a little daunting. Okay, so all right, all right. Now let's move ahead here. Okay, I'll give you a very basic thing. So we have Java code, right? We have Scala code. Okay, when we compile both of that, right now we did not compile, we just interpreted the Scala code. When we compile them, okay, what does it mean by compile? Compile basically leads to something called intermediate language called Java bytecode. It's basically something in a very low level language. We call it Java bytecode. Okay. So this is okay with everybody? Is it making sense to you? So when you compile Java code or Scala code, you get the same bytecode. Okay. Generally, these files are in the form of a.java or b.java or whatever, here these are in the form of a.scala. And these Java bytecodes are in the form of a.class. All right, these are in that format. Now, to run these, we run it on the virtual machine. We call it JVM, or we call it sometimes the hotspot. So basically, this a.class is run on JVM. JVM is different, internally different for Windows, for Mac, for Linux. So there are different, basically the JVM is the one which takes the a.class and executes it on the local machine. Okay, this is what goes in the execution. Okay, JVM is basically, you can think of JVM as if it's an interpreter of this intermediate code. Is it clear to everybody? Yes, for Scala execution, JVM is must. All right. So wherever your Java can run, your Scala can run. Okay. So wherever, a question from Sachin is, in CloudxLab, there are 3-4 Scala Spark tutorial are there. Should we need to do all? It'll be better that you do all. Yeah. It won't be too big. They are very tiny tutorials. Okay. All right. So this is a basic example. Now, one more thing is that when you have just too many files, so what you do is you generally bundle these into something called jar file. Okay. We call that a, like some xyz.jar. So you basically package all the classes into this. This is basically what? Like we create zip files. Like in Unix, we create tar files. In Java, we had a.jar. I hope this cycle is clear enough to you. So you compile your Scala code. It either becomes a.class. If you have many files, you can always bundle them into a.jar. And here, both of them, Scala as well as Java code, it both becomes the same thing and runs everywhere. So if, let's say, you go to your sysadmin and it says that, hey, sysadmin gives you a warning saying, hey, we don't have a Scala virtual machine on our server. So you say that, yeah, it doesn't need a Scala virtual machine. If Java can run, my program can run. All right. So essentially, uh, Scala did a very, very smart move that it compiled to Java bytecode instead of coming up with its own virtual machine. And why do we have this layer generally in case of Java? So that we don't have to write platform specific code. Same code will run on Unix, same code will run on Windows, same code will run on Mac. Everywhere it will run because this JVM is taking the responsibility of executing your bytecode on the individual machines. Okay. All right. So yes, this is a basic example. And now, in the similar way, I wanted to give you a quick demo of Spark Summit. So here, somebody has already written the code in the form of jar. So here, after compiling, it has created the bundle. And this is the entry point. So we are going to just execute this. What it does is it computes the value of pi by estimating the area of circle. Okay, by estimating the area of circle, it is trying to compute. It is trying to estimate the value of pi. Okay. A question from Prashant is just to check again that Scala is an interpreted language or compiled one. It has both the versions. Okay, it has both the versions. It is compiled as well as interpreted. So while we are using Scala interpreter, internally it is compiling the instances and running on JVM for you. And otherwise, it is otherwise it is a compiled language. Okay, it so so you can see the pi is roughly 3.140384. Okay, so you can see that this program has computed the value of pi. Somebody has written this code, which basically utilizes the Spark for something completely not so useful thing called computing the value of pi. And how does it do it? By estimating the area of circle and then computing the value of pi. Okay, to understand how does it work, just take a look at these two pieces of code and you will get the answer. Okay, so a question from Prashant is which one is used in enterprise? In enterprise, both is used. So Scala, same Scala can be run and interpreted. Same Scala could be used as the compiled. Okay, so in enterprises, when you are working, you generally would, while you're coding, you generally would use the interactive shell. And when you are giving in production, you will generally give the compiled code. Okay, so that's how the life cycle is. All right, so we tried Spark Shell, we tried PySpark, and we tried Spark Summit. All right, so we are able to run these commands. All right, and a question from Robin is there a container where we can run Scala program besides JVM? No. Scala is essentially an improved Java, and it runs on JVM. JVM is actually a pretty stable system. Instead of rewriting, they did a very wise thing to just utilize JVM. Okay. A question from Hiten is where do we run Spark Summit, Scala or Python? So we just run on the console, just on the console. Come out of your come out by pressing Control D from Python or Scala prompt, and then on the dollar, the one which shows dollar, that's where you run Spark Summit. Okay, so here this is a program written by somebody which is compiled for us and is being executed on the Spark. So, all right. So somebody has written. You can take a look at this code. It's actually pretty simple. All it does is it finds the area of the circle by estimating probabilistically, and then approximates the value of pi. All right. A question from Bintao is this does not work for me. Spark-Summit. What kind of error are you getting, Bintao? Maybe you are running it on Spark Shell or PySpark. You need to run it on the console. Or maybe on F, it is not working. All right. I can take a look at it. Okay. All right. So can you exit from here? Control D. Yeah. Oh, you are still in TensorBoard. All right. Okay. Press Control C. Yeah. Just copy paste it. Not a Spark Shell. You have to do Spark Summit. So this command need to be executed. It's a Unix command, so it needs to be executed on the Linux cell. Okay, not on the Scala. Okay, you can come out of it and then run the Spark Summit. Okay, you'll have to copy paste again. Oh, you have to make it a single file. Open the notepad. You have to make it a single line. Put it in notepad and make it a single line. Okay. Uh, in the meantime, there is a question from Hiten. There is too much of text being spit out. It's hard to see the result. Is there a way to avoid this? Yes, there is a way. We can change the log label, and yeah, we can change the log label, but we'll cover this soon. Okay, so you can see that pi is estimated go up. Yeah, you can see pi is roughly 3.14 at the top of the screen. You can see not here. It won't be there. The SC won't be here. Okay, because this is a Linux shell. SC would be either in PySpark or there. Go up. I'll show you. Go up a bit slowly. Yeah, there. You can see there was a line saying pi is roughly this. Go slowly down. Stop, stop here. So yes, you're able to, basically it was able to compute that. All right. If you change the, instead of 10 iterations, if you put like 20 iterations, it's going to take longer time and give you a more precise value. Okay. So great. Today we did hands-on with respect to Spark. I know that some of the commands will not be clear right now, but as we move ahead, you will have far more clarity on what is going on with Spark instead of the theory. Okay. So we would like to go into more details from the next session. And from the next session, first we will launch the different version, Spark 2 version of the same thing. Okay, here are the instructions on launching the Spark 2. All you can do is export these two variables and execute either of these commands. Okay. All right. The entire course is, I've tried to keep it hands-on. There are some concepts that I need to describe, and only those parts will be theory. Okay. Okay. If you are going to break it down into 100, it's going to take a long time. A question from Binta is, why do we need to launch the lower version of Spark? Actually, that's the one that came with HDP. The default version that comes with HDP is generally really old, and that's why we are using the default version, while we have installed newer versions here. Okay. All right, so great. We will continue from here in the next session. And SDP means Hortonworks Data Platform. It's nothing but the Hortonworks package. They have packaged the Apache Hadoop. Apache Hadoop is open source. Either we install by ourselves or use their installers using Hortonworks installer or Cloudera's installer. So we first use the Hortonworks installer to install our lab, and then we added the Cloudera components. All right, great set of questions. I look forward to see the similar interaction next week. Bye-bye, have a good day. All right, we will continue from here in the next session. Next session we'll be starting with RDD, and then we'll be going into more details. All right, thank you everyone. I hope the session was useful. All right, we're going to do this all the time. Do the practical first and then theory next. Okay, so the questions should come from you, that what is this, what is that, instead of me just trying to say tell theory and then showing the hands-on. Okay, great. So thank you, David. So looks like for 1000 the accuracy is better. And how much is value of pi is in general? Yes, So this is 3.159. Okay. 400, the the accuracy was better, right? All right. So great, great. All right. So thank you, everyone. Have a good day and good week ahead. Bye bye.